Well, we're going to take a look at some leveling details. Hopefully most people are pretty good with this stuff. We're going to take a look at differential profile, trigonometric, reciprocal. So obviously I think everybody knows elevation is a vertical distance measured along a vertical line. So you're above or below some given datum. Three primary types of leveling that we'll look at. Well, really steel taping is one that's great. Particularly for high-rise building type stuff. Getting a ground level elevation up 5 floors is real easy if you can drop a steel tape down the side of a column, but that's not traditional leveling. So the kind of traditional more stuff we'll see is differential and trigonometric. So steel taping is direct. You're just reading that vertical distance, but the key idea that, of course, you have to be parallel with the vertical line. If you're out of line with that, then you're not getting a good vertical distance. Differential leveling is a direct technique. It's probably one of the better, more preferred methods, especially if you're doing control still. Because you are reading a direct vertical distance and there's a lot of checks and balances within it. Differential comes in several types of things you can do or techniques. You can run what's either called a loop or a line of levels. A loop is just like a loop in our closed traverse in the sense that you start at one bench and you end at the same bench. A line of levels is where you would run from one bench of known elevation to another bench of known elevation, provided those two benches are in the same system. And that's a key idea, because if they're not, then you're not going to get any closure. Profile leveling is just really a type of differential leveling where you are now incorporating what we call side shots into the loop. Some people also refer to them as rod shots or intermediate foresights. Three-wire leveling is a type of technique where you're reading an upper thread, a middle thread, and a lower thread, and this guarantees that you're getting a proper reading and you're not making mistakes. So differential leveling equipment, obviously level, tripod, level rod of some kind. Okay. Differential leveling basically has two equations. So we would take the HI of any point is going to be equal to the elevation of the point we're coming from plus the backside reading on that. And then we just turn the level to whatever point we want to go to that has no elevation on it. We put the rod on that and we just take and read that rod. That's our foresight reading. So then our HI minus our foresight reading is our elevation. And that process then is just repeated over and over and over. For a closed loop, of a loop where you're coming from a point to a known, from the starting point to the same starting point, you can sum your backsides and sum your foresights and add them together algebraically. So when you do this, we're assuming that you understand that backsides are plus and foresights are minus. We'll talk about that in a minute. But that value then should theoretically be 0, but of course it can always be 0, but we're always looking for some kind of loop misclosure. So these are typical level nodes. What we're looking at here is this is your location. Might be a station, it might be a location, whatever. So we have your backside column, foresight, and HI, and then rod and elevation. Now, if you're not doing profile leveling, you're not using this column. So if we're just doing a straight loop, we don't worry about that. Backsides are also considered plus sites, so these are usually additions, and these are negatives. Rods will always be negative as well when we get into that. So this is an example of a very simple level loop. Notice this is a true loop because we're starting at point A, benchmark A, and we are ending at benchmark A. So we're starting at benchmark A that has a known elevation of 528. We took a backside reading, 677. We add, just like the equation said, we add the backside to the elevation to get an HI. So we turn the scope to another direction. At another point, we take a foresight reading on that. We subtract the foresight from this HI, which gives us this elevation here. We pick up the instrument and we set up somewhere between turning point 1 and turning point 2. So then what that does allows us to now get a backside on turning point 1. So we're going to take the elevation and add the backside to get the new HI. Then we take a foresight reading on turning point 2. We subtract that from that, and it comes like this. And then we pick up again between here and here, between our temporary benchmark and our turning point 2. We set our instrument up, We take a backside reading on turning point 2. We add the elevation here to get the new HI. We take the foresight reading, we subtract, so you can just notice we keep doing that. So at the end, we're benching back into benchmark A, and this final one should agree. Notice it has a beautiful misclosure. So misclosure is defined as the sum of this minus the sum of this, or plus it if you want to think of it this way, because these are always plus and minus values. So if this agrees, then this should agree also. So one of the things you can always do is take this number, bring it down here, and subtract it from this. The number you get down here should agree with this, both in terms of sign and magnitude. Okay, so that's a double check in your math. Okay. Profile leveling is just a type of differential leveling. Basically what we're doing though, instead of setting up between a whole lot of points, we're staying at one setup and doing side shots, if you will, off of that. So these are called rod shots. They're called intermediate foresights. They're typically negative. These are great for doing grade stakes along a highway or something. You don't want to set up every 25 feet. Okay, you're going to be there forever. The downside to this is that all of your rod shots or side shots have no check. So they're not part of the loop. They're excluded from the loop. So if you blow one of those or several of them, there's going to be no check, where your loop internally will have a check. So this is an example of utilizing that concept of profile leveling notes. And it's also another thing that's nice about this. This is called a line of levels, because you'll notice right here, we're starting at a benchmark A and we're going to a benchmark B. So we must, in order to loop this properly, we would have to have a published elevation of A and a published elevation of B. Now the other thing is, in this set of notes right now, we've got backsights and foresights, and we also have rod shots. We're going to ignore the rod shots when we come through this initially. That way we're going to make sure that we have a proper loop, and our loop closes great, and then we're going to come back in and do the rod shots. So if you try to do them together, usually you'll make a mistake. So the first thing you can do here, you can sum backsights and foresights, but notice when you come here, you have a 2.56 difference. Well, that's not a bust. Okay, because we're starting at A and B. What this is telling me is this is the difference in elevation between A and B. So we'll figure out whether we have a misclosure or not. So this isn't going to tell me if I do a line of levels, but I still do it the same way. I start out with my elevation, add my backsight to it, I get my HI. So I'm going to ignore all these for now. I'm going to subtract this here, brings that elevation of my turning point. Add those together, I get my new HI, I just continue that process until I get down to the bottom here. So this is my closing elevation that I came up with of benchmark B, right there. That's my closing elevation. So what I do is, this 36301 is the published value of benchmark B. So I'm taking my calculated value of B minus the published value, that's my actual misclosure. So notice this is not a misclosure, it's a difference. Okay. So now once we have we know that we've got good data, now we're going to come back in and we're going to do the rest of the points. So what we see here now, the calculation of the rod shots are very simple. All of these group right here, okay, these are all being taken from the same HI. So we're going to take this HI right here and we're going to store it, and we're just going to recall minus that equals that, recall minus that equals that, recall minus that equals that. So that's just continually happening for that band. Then we come down to this group here in this area, and we have a new HI that we're going to store. So we take the 36650, store that number, subtract that, gives me that, subtract that, gives me that. We can just do those subtractions. The last group here, do the same thing with that HI. So always do your loop first when you're doing this type of survey notes, and then do your rod shots secondarily, and you won't make a mistake. So 3-wire leveling, it is a type of differential leveling. In this case, we're taking and making 3 readings instead of a single. So when you look at your level, you have 3 hairs in there. The middle one is what you normally read, but you have an upper and a lower, and those are referred to as stadia hairs. Okay, so they will also yield for you distance, but they're very good for doing precise work. So what this keeps us from doing is any kind of blunder. Gives you the 3 readings, it's just a little bit more work to do, and the stadia measurement gives you a distance in how far you are from the instrument to the level rod. So this is the way it works, very simple. For your backside and your foresight readings, you just take your upper reading, your middle reading, and your lower reading, you add those together and you divide them by 3. So instead of reading one value for your foresight or your backside, you're reading 3. So your notes get quite expanded when you're doing 3-wire leveling. But when we take these 3, we add them together and divide by 3, they should agree with the middle crosshair very closely. And if they don't, then you've got an issue in your reading. The other thing you can do is you can take your upper reading, your upper hair, minus your lower stadia hair, and multiply it by your stadia constant, which for the US, most of the instruments are set to 100. So when you do that, that's the distance in feet. So your upper reading minus your lower reading times 100 will tell you how many feet you are away from your instrument to your rod. And that's good because if you're trying to balance backside and foresight, you can determine whether you're balancing distance. Good. Trigonometric leveling is an indirect way of determining elevation. And it's not as good as differential. It does typically yield a quicker result. It's great for large elevation change where you don't have the time or the ability to, let's say, run a loop up and down the side of a mountain. But if you really want good numbers, you're going to have to make sure you do it several different ways. But trigonometric is quick. Basically, you have to calculate a vertical difference. You're taking your slope and your zenith angle and determining that. And then essentially, you're going to have elevation calculation by your known elevation, plus your HI, plus your vertical difference, minus your rod. Okay, so here's a schematic of that trigonometric process. Saying you have a total station instrument set up at point A. So what you're going to measure is the height of that. We call that the HI. You'd get a zenith angle, and you would get a slope distance. Slope distance and the zenith angle are going to yield for you a vertical difference. And then you're going to have a height of the reflector. Like that. So what you're doing is essentially taking elevation today plus HI. In this case, we're adding the vertical difference, and we would be subtracting the rod. So we could express that elevation B is elevation A plus your HI plus your vertical difference minus your height of a reflector. So this is typically considered always plus because if you're looking uphill, you're going to get a positive vertical difference with a zenith. If you're looking downhill, you're going to get a negative vertical distance with a zenith. So we would add that. So this can change, positive or negative. This is almost always going to be plus, and that's going to almost always be minus. Okay? So that's how you would work a typical problem using a trigonometric problem. So if we look at this problem with some numbers on it, let's assume that we have an elevation of 800 here. We measured this height to the center of my total station of 5.42. My rod is set to 5.63. And we measure a zenith angle and slope distance. Now, modern total stations, if you're using them, they're going to calculate this guy for you. But if we don't have that capability, then you calculate it by your distance. 26 times the cosine of the zenith angle, 70 degrees, 1232. And since I'm uphill, or since I'm using a zenith angle, zenith will go from 0 to 360, so your calculator should give you the proper result. So if I key that in, times my slope, so it gives me a positive 110 point, basically 39 feet. So I have everything I need to calculate this now. Elevation B, I'm going to to be equal to 800 plus the 542 HI plus the vertical difference, and the vertical difference is plus. The rod is always minus. So what we're going to do, 910.18 feet. So basically we had 110 feet of vertical change, which if you're doing that with a bench tradition, the differential leveling might take you a while to achieve. The beauty is that we get a pretty good number here, but just keep in mind it's not going to be as good because you have potential source of error here, potential source of error here, potential source of here, and you also have refraction and those kind of things happen. Okay, so for trig leveling equipment, if you're doing traditional, you're going to use a total station, tripod reflector, plumbing pole. If you're using anything with parts per million for your EDM, you need a thermometer, barometer, but a folding rule to get your HIs and your heights. So another thing that you might see in a typical test is talking about curvature and refraction errors and associated leveling. First of all, unless your distances are huge, you're not going to see it anyway. So this equation gives you the correction for curvature and the correction for refraction. Now both of these things are happening together. So curvature is usually causing more error in your level readings, and it's usually giving, what it's doing is it's creating a higher reading than it should be actually expressed in. And refraction will actually kind of counteract the effect of curvature, but it reduces it only by about 14%. So when you combine these two, you get what's called the combined effect. But again, the reality is that these things are very, very small errors unless you're out 500 feet or more, which most people are not using that differentially or not even seeing it. So you usually wouldn't have to see it, but the way you use this, it's the miles in distance from your instrument to your rod. So you have to measure that in terms of miles. That number squared times that gives you how many feet you have of air, and this is thousands of feet is the way that works.